Hello, everyone. Um, Despite the fact that on Tuesday we said there wasn't a meeting today, the calendar did correctly say it. Uh, so, surprise! Um, we're reviewing uh, JSON polymorphic serialization, which instead of our standard GitHub quick reviews title, I've actually tried to title today's uh, series, episode, stream thing. Words. Great. All right. I should not be talking, so I'll let someone else. Uh, Supporting polymorphic serialization through new option. This relates to JSON serializer 299037, and I will click.
Okay, so let me give some background on this feature. This is actually one of many polymorphic serialization features that we're planning for system text JSON. For .NET 6, we'll only be focusing on this one, which is, I guess, an extension of the way that we currently do polymorphism, but restricted to system.object member types. So I've written up a simple example here. Consider this type hierarchy, inspiringly named foo, bar, and vase. Currently, if you try to serialize instances of either type in this hierarchy and you serialize it using the static type foo, then the JSON schema would always invariably be derived from the type foo, which is the right default behavior, in my opinion. But there have been requests for extending effectively polymorphic support for arbitrary class hierarchies. Again, I should maybe point out that under the current behavior shipped in .NET 5 in system text JSON, when you have members, either be the root type or the property type of a nested object of type object, then the serializer will dispatch to the converter generated from the runtime type of the given object instance. So this is a proposal to extend this to class hierarchies. Could you scroll down a bit, please? So, yeah, that's fine. So under the current proposal, the idea is that you basically decorate the base class with a JSON polymorphic type attribute. And now when you try to run the same thing with serializing foo, bar, and vase using foo as a static type, then actually it will end up using the JSON converter corresponding to the individual runtime type of the provided parameter. And that's more or less the design. Forgot what I was going to say, but yeah, basically polymorphism applies to nested values as well. So if you have a property of type foo, again, it will dispatch to the corresponding to the converter corresponding to the runtime type, and it will serialize all the relevant properties for you. It might be worth pointing out that this feature has absolutely no provision for deserialization. It just provides a mechanism for, I guess, dumping all your sensitive properties of your type hierarchy on the wire. That's there is another design proposal that has been cut from .NET 6 that concerns support for both serialization and deserialization. It is an orthogonal feature, and it involves serializing type identifiers on the wire, which I know excites Barry.
Does
Obviously,
the attribute apply just, oh, sorry.
Oh, no, go ahead.
Does the attribute just apply to the thing being serialized, or would it work on properties?
Under the current design, it only applies to the type definition, although I guess we could extend it for members as well, properties.
Eric, the type scrolled off the screen, so I missed it. Does Baz derive from bar or from foo?
It derives from bar.
So bar doesn't need the attribute as well. You put the attribute on the base class, and then the entire hierarchy is serializable.
Good question. So the attribute is not inherited by derived types. So just because we've declared foo to be polymorphic, that doesn't transfer to any derived type. So bar is not by extension polymorphic. And the rationale behind this is extending what we do with object, because object is always polymorphic. You can't opt out of that behavior, but any type deriving from object is not automatically polymorphic because of this.
So then I'm not understanding the sample at the end there. How is C serialized out?
Which sample?
If I only add JSON polymorphic type to foo, how
So-
am I?
So it only informs how so basically it only informs how the static type foo is meant to be serialized. So any derived type from foo will be serialized polymorphically. But if I were to replace foo with bar in the angle bracket when I was serializing baz, then it would not do a polymorphic dispatch.
Right, but just to make sure I understand it when I mark foo, not only does that allow bar's properties to be serialized out, it also allows baz's properties to be serialized out, even though bar doesn't have the attribute. So it's recursive through the whole hierarchy.
Right, provided that the static type is foo.
Okay, and that avoids the reason there's a lot of debate about what to serialize, based on what type you specify. And the concern was around your derived types might have sensitive state. We believe that is sufficiently mitigated just by attributing the base type, that someone's not, you annotate your employee class as serializable, and then someone derives from that, hourly, but then someone derives from that with social security number. That's still going to serialize out the social security number. We're okay with that.
To be very honest, that was not considered when I was designing this feature. So
I also don't have an opinion or an answer. I just want to make sure we're doing things that are consistent with decisions that have already been made.
Right. So that was not considered, and that was primarily because the design was this feature was designed with people that were kind of so I would say that this design was offered to people that explicitly wanted the entire type hierarchy to be emitted onto the wire as is. I recognize that this has substantial, data leak ramifications, but that was basically what users were asking in this issue. Now we could change this and change it into a model where you have to explicitly opt in individual derived types. But I believe the appetite was to, I have an open hierarchy. I might be having an assembly that defines another derived type, which I don't have access to in the base type. And I want that to be emitted onto the wire as well. For what it's worth, the other polymorphic serialization feature where you're actually emitting type identifiers to the wire, in that design, derived types have to be explicitly opted in, if that makes sense. And that relates to security considerations on deserialization.
So why don't these security considerations apply here? I mean, you say that people may want to serialize a derived type in another library that they don't have access to. And, that seems to me to be a very good reason not to allow it, because that derived type may, you may have some innocent class somewhere, and then the derived type has a username and password in it.
Mm-hmm.
So generally how I'm going to feel about this feature, period. And allowing people to explicitly opt in objects that they don't own feels wrong. The other question I have, and I was going to leave it to later, but now that I'm starting to rant, I may as well throw it in here, is will any framework classes have this attribute applied by default? And if the answer is yes, what do I need to do to stop that happening?
So in order to opt out of something that has the attribute already applied to it, you would need to, so the same flag can basically be specified in the JSON serializer options class. So it is exposing a predicate that you can set, and you would be able to sort of opt out of polymorphic behavior for a given type, even though it might have the attribute.
But unrelated question.
It's still up to the developer to do that, is it not, rather than the owner of that type? So say, for example, AAD has a type that they don't want to be polymorphic, to be serialized in such a way, but someone will derive from it and slam it on the derived. I'm concerned that people will apply this to things that it most certainly should not be applied to and start doing really weird things. I mean, like anything, I believe it should be opt-in. You know, it should be attributes all the way down for opting into this sort of thing. Otherwise, we end up with where we used to be with XML serializer, which would, you know, you're having to opt out individual attributes rather that are unsafe, rather than opt in the ones that are safe.
Mm-hmm.
Yeah, it seems to me like you want this attribute on the derived type, and then basically when you serialize an instance, you find the base, like the closest base that still has the attribute, right? So if, in your example, if you scroll up again, if let's say bar has the attribute and foo has the attribute and it's serialized baz, then baz would be serialized as bar.
Yeah, I would say
bars
that
is the closest one that still has the attribute. That seems more logical than the inverse, because the other thing I don't like is, now in your example, if I serialize as foo, I get more state than if I serialize as bar and the instance is a baz. And that seems very unintuitive to me. Like why would you get more state when you serialize it to a base type?
I would say that this reflects the current design of system.object, which is already polymorphic, and it effectively behaves that way. So basically, there is a Boolean flag that has been hardwired for the system.object type. And whenever you have a property or a root value that has a static type of object, then whatever exists in sort of the converter corresponding to the runtime type will be emitting onto the wire. So I would probably say that this security consideration already applies to system.json.
I mean, that's fair, but I think it's also fair to say object is special. I wouldn't necessarily say that, and we should take that design and roll it out for the entire hierarchy. Because I mean, object is special for boxing, and it's just a untyped anything kind of thing, right? So I feel like even if we have this discrepancy, I think people would maybe even find this still intuitive. But like, I think the proposal here doesn't seem intuitive to me.
Yeah, and again, what you mentioned about this only applying. So you basically said that you find it strange that the attribute is not inherited by derived types. But again, this is reflecting the design of how polymorphism currently works, where only the top level type is polymorphic, but anything under that type is not polymorphic.
Right. No, I think that based on what Barry said, I think it is fair to say, like, I think the deriving is the wrong direction. I would just say all the things that all the leaves have to be annotated, and if somebody derives from a leaf and adds more state, unless they apply the attribute, that state is never going to be serialized. And I think that's generally the right behavior, because then basically you get 100% control and people don't accidentally leak state ever.
The other thing is, I mean, I understand the argument that system.object does this already, but system.object is the main case that of something that should never ever be marked as polymorphic serializable. It is in fact the reason why this thing probably shouldn't exist. If we applied this to system.object, we've reintroduced remote code execution. We have basically reintroduced binary formatter yet again. So using system.object as a base for the design, pun intended, is probably not the right way to think about it, in my view. But also, the pun was glorious.
I mean, let me try to understand what Eric was saying. So basically, what Eric was saying, I think, is that if you have a property on a POCO today that is typed as object, we would serialize the type whatever the actual runtime type is. Is that correct?
Correct.
So,
So
stepping back like 1,000. Oh, sorry.
No. Now to Barry's point, like, is this considered a bug or a feature? Like, because I mean, at this point, the question becomes like, if we think that's a major issue, maybe we should just make it opt in rather, or opt out, or whatever the I guess opt out would be less breaking, obviously, because we shipped that behavior already.
I mean, this was definitely a feature that was discussed in V1. System object is treated specially, and it's because it's explicitly system object. It means that you can assign any type to it, and it's actually explicit because of that type. So it was thought that if you do have a system object type, we want to also support. If you want polymorphic support, you have to change your type of your property or element to system object to kind of opt in. That's what we decided in V1 in the serializer, which also then allows you to do a round tripping. And during deserialize, we create a JSON element type, which is a loosely typed, way to get your data. So I mean, it was definitely a feature, not a bug.
Can someone explain to me how the attribute's better than just the serializer option or serializing object? I don't get the use case, to be honest.
Well, you want it strongly typed, right? I mean, if in your DTO, if you have, let's say, a property called strategy, and that has a virtual method on it that you expect derived types to override, it's kind of shitty if you have to like cast this from object to strategy every single time you access the deserialized object, right?
I thought we were talking about serialize.
Well, I mean, I think it applies to deserialized as well.
This design doesn't support deserialization because it's not emitting any type data.
Oh,
Yeah, this is writing only.
Yep.
Oh, this is
right.
only
So I
one
still
direction.
don't get it. Like, I don't get what the attribute's getting us over the global option or just serializing object.
Right. Why wouldn't you just say serialize angle bracket object open paren foo bar path?
Yeah.
Like that gets you the behavior that you get here.
Well, object is, and I think that's for reasons it ended up only going one level deep.
No,
Right.
he said it uses the runtime.
Really?
Type.
Well,
Well, it'll go as many levels as the graph is, as long as the other properties are object.
But no, but if I have a POCO with a field or a property of type foo, I would have to change that property to be of type object to get the polymorphic behavior, right?
Right.
Yep.
Right. Whereas
What about
with
the global
attribute-
option? That was at the top. Oh, sorry.
Right. No, I'm just talking about the why it's not just change foo to object in the generic type parameter, because there's also the case. I had the same question as Stefan though about why is this design better than just having an opt-in option on the options? How many times can I say option in the same sentence? That basically says do polymorphic for everything.
As in one global flag?
On the options. So instance global to the instance of the options being used.
So if I get the proposal correctly, you're saying that there should be one Boolean flag in the serializer option that basically opens the floodgates and makes everything polymorphic?
Yeah, I'm asking, or I think Stefan's asking, why is this design better than that design?
So that was actually the initial proposal. So if you scroll up into the original post, what Steve actually proposed, that was the design. And I guess I ended up not doing that because I assumed that people might want, finer grain control over, which hierarchies you want to impose this on.
Makes sense, yeah.
At that point, would you want it to be like member attributes, right? Like if it's applying to like whether you interpret the member as an object versus its like concrete type. But like that does honestly seem a little niche, whatever. To me.
Well, I mean, I can see both member level decoration, which came up earlier, and the type one. Like if you know that you're having, some sort of three variant thing with a base class that you're trying to send over the wire, you'd be like, it's the base class and do this polymorphically, just figure out which set of parameters you need to encode. And that you've decided this does apply to your type, but you don't want everything to do that. It's just this one little piece of data. And you can write it with a converter, but I'm not saying it's the most valuable interpretation, I just see it.
Yeah.
I mean, I think the key scenario for member level would be if you don't own the types, right?
Well, that's
But then the problem is
this is
kind
for.
of skeptical, right? Yeah, I guess that, yeah. I mean, honestly, if you have that, then why would you ever want the member level?
Well,
I mean, if you don't own the types, write your own POCO and then just do a transfer in and out. Stop messing around with other people's stuff. Bad. Slapping the wrist.
yes, be intentional about your serialization.
Right? And you just
Yeah, it's just hard in practice. Or more work, I should say. To me, the reason why I don't like member level is it feels error prone.
It's
Like, to me, this seems like, well, I mean, is it? I mean, honestly, like if I declare the types that I want the polymorphic behavior for, then I mean, it's a function of the type. It's not a function of where the type lives, right?
Well, but now we're back to Steve Tobe's point of, take our model of you extended a type because of programmatic reasons. You're not necessarily aware that it's being serialized somewhere, and you're not aware that, the base class of your base class of your base class just declared itself to be JSON polymorphic. That wasn't part of your object design when you made something be a property instead of a method. You didn't know it was going through the JSON serializer, so you didn't put JSON ignore on it.
So I would agree with that. That's why I would say, like, to me, I think the design we have should still not talk about bases. It should talk about the most derived. You should basically annotate the leaves. Like, that's my opinion. Like, I would not say treat strategy as polymorphic and now suddenly everybody who's deriving from strategy gets polymorphic behavior. I think that's wrong. I think you should say, here's the types that I want to serialize. And if something is derived from that, find the closest one that's marked as serialized.
In that design, would you still make it possible for the user to say, screw it, just opt in for everything? So open hierarchy, would that be a valid option under the design you're considering?
I mean, I would wonder why you would want that, because I mean, at that point, like if you literally say take anything, at that point you probably have something like, literally object. Like, do you actually care? Like, I mean, because I mean, in almost all polymorphic cases, you talk about a closed hierarchy, right?
Yeah, I mean, for the record, I don't believe in open hierarchies, but I would say that there might be use cases where, for reasons that are beyond me, a user might say, I don't know what the hierarchy will be at runtime, just opt into everything. It sounds like a valid scenario for me, particularly given the fact that we already do this for object.
I mean, it just makes it be the JSON stringify function.
Well, also makes it into yet another remote code execution. If you're just gonna opt in an entire hierarchy of stuff, I mean, at that point, why don't we just run on Apache struts or in Java struts? Because that's what we're reintroducing.
Well, RCE requires that we support polymorphic deserialization, which this proposal does not support.
Ah, okay. I kind of figured that at some point someone will suggest this because we've done it one way. It's going to have to be deserialized back the other, and that's kind of what I'm concerned about.
No. So this proposal does not emit any type metadata on the wire. So deserialization is, unless you're deserializing in a dynamically typed, runtime, deserialization is out of the question. The other feature that has been cut from 6, which does support emitting metadata and deserializing, that actually requires opting into individual derived types. But I
think these things are related. Like, I mean, why would I want to have one but not the other ever? Like, it seems to me if you have a closed hierarchy, at some point you would want deserialization. And so I think whatever mechanism we have there seems we should design it such that when you use the other side, like it's not a completely like competing proposal, right? And I think for the other side, as you said, you probably want you list every single type you want to deserialize,
Yeah,
and
I
then
would say, sorry,
yeah, and
I
then you
would say
basically
there
have
are,
some sort of tag or type information that you emit, right? And at which point, like an open-ended hierarchy would just feel odd, right?
I would say that there are valid use cases for both features, and they would not be used for the same purpose. The other feature emits metadata on the wire, and in some cases it might be noisy. Like if you're emitting, for example, a polymorphic collection, you end up having a JSON object with some metadata and then a nested array, and that might be undesirable if whoever you're sending this data to does not care about the serialization. They just want I guess, a rich representation of your object graph in JSON. That would be the use case for this feature. The other feature where you are emitting metadata and where you are doing all this opting into derived types and what have you, there you're more interested about round-tripping data in sort of homogeneous .NET processes. And it's more applicable when you want to like serialize discriminated unions and things like that. So very different use cases.
Yeah,
Yeah,
this
I'm
is
not so
more
much
server to
questioning whether.
JavaScript.
Yeah, I mean, I don't question that there are cases where the receiver is not .NET. It just seems like there will be cases where both exist, and I'm just asserting that it would be nice to have a design where serialization and deserialization feel like, counterparts to each other rather than completely disjoint feature sets with different
Yeah.
opt-in mechanisms.
So
And
that
just to note that there is another feature that we have, and it's called extension data. So if you do serialize with this feature, that won't serialize metadata, if you add the extension data attribute to a dictionary property, we will put the quote unquote overflow properties inside of that dictionary. So you can kind of get round tripping with this model. It's just that you have to look inside this dictionary to get the other state.
So what do you consider overflow state? Basically state that is on the derived instance but not statically typed as such?
Well, in the scenario, yeah. So in the scenario that Eric pointed out, if you serialize something like Baz polymorphically, the variable type is foo or whatever,
Mm-hmm.
they'll serialize it, polymorphically, and when you deserialize it back to foo, as long as foo has a data extension property on it, the
Oh, I
extra
see.
JSON will be assigned to this dictionary. And for this release, since we have the JSON nodes class, instead of a dictionary or JSON element, it can be a JSON object, which supports edits. So this feature, along with the new JSON object, plus the existing extension data, would allow you to kind of do round tripping in a kind of a not perfect way, but it would work at least.
I mean, I think it makes sense to say, like, let's discuss serialization independent of deserialization, but I feel like from a design standpoint, it seems deserialization would mostly prescribe a closed hierarchy, right? So the thing is now, if on this feature we have a global switch that says, any type basically, right? Then that would basically mean we wouldn't be able to deserialize that, right? And so then the question is, what's the how do we we can't really throw an exception at that point, because what would we even do? Because we can't tell necessarily, but that's why I'm not a fan of that design. Like I would prefer if serialization is basically you list all the types you want, either as an attribute on the type, or the supported polymorphic types property on the JSON serializer options, because that one at least I can see how we could make that deserializable without introducing massive security holds. And then anybody who has an open hierarchy and doesn't know the types, I'd be like, sorry, I can't do that. But it seems to me like you should be able to write an algorithm that finds all the types and puts them in there. Like, I mean, because clearly you have a closed process, right? With at some point you walk the object graph, and you should be able to tell the types at that point.
at runtime, yeah.
Yeah, which, I mean, you populate the serialization options at runtime, right? So like You might have to write some code that does that, but like that seems you should be able to list the types you want. But at that point, the person clearly opts into the behavior, right? And then they should not be shocked if the types that are listed there are actually being serialized and deserialized.
So I guess the question then is whether we want to change this into a model where you would have to opt in to specific derived types. And one lazy way of doing this, I put it in the chat, is we can just change the predicate from accepting one type parameter into one that accepts two type parameters. So the base type, the derived type, and returns a Boolean. And that would make, I guess, both the people that want a more restricted model happy, and also the people that don't care and want to opt into everything.
So what would the types be in this case?
So you, instead of a func from type to bool, you would have a func from type to bool. Mm-hmm. So the first argument would be the base class, the second argument would be the derived class, and it would return a Boolean indicating whether a runtime type of the derived type should be serialized polymorphically given the static base class.
So declared type, comma, runtime type, to yes or no.
Yeah. And matching attributes, obviously.
I'm wondering whether
that be very terrible performance?
That would be cached, I presume.
Well, I mean, somewhere you're going to have to... Well, it means you're going to have to call getType on every object, because you now no longer have a static way of... Unless there's also a thing that you have to put on the property to say this property supports polymorphism, you would say for every value you ever see, you have to call getType, which, I mean, maybe that's cheap. I was just given the impression, like 15 years ago that was less cheap than you might think.
No, I think you're making a good point, because you can't really pre-compute everything for a given base type.
Because like it would make sense once you've decided polymorphism might be appropriate here as a filtering mechanism. The question is, how do you determine polymorphism might be appropriate here? And maybe it's if you register this delegate, then yep, you call getType on literally every sub value.
How would we how would this work with source generation? I mean, source generation would only work with the attributes, right? So you wouldn't be able to support the func that talks in terms of reflection types, right? So you would basically say, like, if we wanted to opt in other people's types, we would basically have to invent some sort of assembly level attribute, or sorry, not assembly level, like an attribute we put on the JSON. I forgot what it's called, the JSON context, where you can say, this, serialize this thing as in a polymorphically kind of thing, right? And so I'm wondering, like, do we want to introduce the supported polymorphic types thing that talks in terms of funcs when we know we can't do the source-based thing? Or are we thinking, like, people that don't care about source generation, they will just use this one, and people that care about source generation, they will apply the attributes?
Yeah, the func thingy is certainly for people that are not using source generation for the context of these types, at least.
Yeah, my recollection, and please correct me if I'm wrong, is that source generation basically ended up with, it produces two paths, one where you didn't have custom options and one where you did. So in the one where you don't have custom options, it would know there would be no polymorphism, so it would still be able to do fast generation. It's if you used custom options that now it's going to not be able to trim anything out because you may have done literally anything.
Yeah, we have two modes with source generation, where in one mode it's what you describe, where you tell us predefined set of options we can support in like serialization logic, and in another mode we basically do what the serializer does at runtime, but at compile time instead. So all the reflection that we can do statically, we can do it. So we create the same like JSON type infos, like the same type information. So features that we would need to use reflection at runtime to support, to understand is what we would be able to support in the source gen. So if the implementation for understanding the closure means doing reflecting on types, then it's hierarchies of we wouldn't be able to support it in source gen mode. So the couple of modes in source gen is the summary.
So, Laomi, in the source gen, is it possible to detect if we have this attribute approach that we need to call object.getType and serialize a different set of, maybe additional set of properties, or forward to a different area code that knows how to serialize the base, our derived types?
So for source gen, you need to indicate the base type and all the possible runtime types. Then at runtime, you would have to call type getType, which I think is fine. And that type that is returned needs to have been indicated beforehand at compile time. Then that way we can look up the metadata. We have a mechanism to retrieve it.
But without metadata, I mean, we don't have to solve this now. This is like a low-level discussion, but I was wondering if there is a fast path option with this feature that doesn't require looking up to this dictionary, for example.
I think in principle, in fastpath source generation, you might be able to replace object.getType with runtime type tests if you know the list of derived types that are supported. And I think Laomi shared some code that was pseudocode that was doing precisely that.
I mean, it's still based on, at least that was still based on calling getType. Is that a thing that we can do at runtime in the fast path? So we just call getType on the type, and then we can still call generated serialization logic for all of the derived types. But you mentioned other type checks. What would that look like?
So basically, it would be a switch statement on the individual list of derived types. If you do source generation, you could say you could generate that basically a switch statement that checks through all the supported types in your hierarchy and dispatches to the individual converter.
But we still, the entry point there is still the declared type at that point. So
yes,
what are we switching on? The result of getType?
Yes.
Well, the result of as.
The result of as.
Oh, I see. Okay.
Well,
is it
order.
different?
Well, type or value.getType requires that the reflection object of that type be created, which maybe is only expensive the first time the type object has to be created. But the is check is a runtime thing that doesn't actually involve reflection.
Fair enough.
Yeah, that's fine.
But I think that's a different discussion, I guess. There's certainly ideas we can iterate on. But I guess that seems to suggest that perhaps a model where you explicitly specify the derived types might also be more friendly for the fastpath source gen.
Right.
Yeah, would absolutely need to know them, because otherwise won't have generated anything to support their serialization.
Yeah, which.
Okay.
I don't know if that means it's a collection of types that are polymorphic safe, and if you see any static type is one of these types, then if the runtime type is any of these other things, which you can filter to the appropriate scopes, or a dictionary, so that they have to provide the forward mapping for you in an easier way. But yeah, so I don't quite know what it would look like. The problem with the attribute model is if you're putting on the base class all the known derived types, which is what the SOAP formatter did, I think, is that you can't have your type hierarchy span assemblies because the base type won't know about something in a future assembly. So you have to figure out how you can paint these things and at what layer you could do so.
Well, that's why I generally think that you should always do it from the derived rather than from the base, because that also avoids the cycle, and it avoids the I have to know what my derived types are doing problem where I don't know whether it's safe, right?
Right, but now you're back to the when the serializer or the generated code is doing a thing, it needs to understand when I see the node value here, where did value come from? There wasn't a value. Somewhere the word value came. Yeah. When I see the node value, should I even be looking to see if polymorphism is appropriate for this node? And the only thing it knows is that value was declared to be of type foo. So somewhere the type foo needs to make this other new system wake up and start taking action. Or you need to paint this property as supports polymorphism.
So, I mean, in summary, then, I think what we're saying is that if we have a closed type hierarchy of all the possible derived types, and we know that at design time, we can do fast path. If we don't know it at design time, then the fast path, won't work, or it has to use some different approach. And with the current model, where we specify the serializable attribute on the base type, we don't know all the drive types, right? So if we want to support the fast path, we need the other model where we specify it on the derived types instead.
But I mean, could it be the case that when you're opting for a specific derived type, you might be enabling polymorphism for a different base class for which polymorphism would be inappropriate? Like, to give you an example, if I have an interface ifoo that is not marked as polymorphic, and I have some class implementing that interface and a derived class from that class, and I mark the derived class as polymorphic because my intention is to serialize I should be naming all these things, I'm sorry. But suppose you have an interface ifoo, a class foo that implements ifoo, and then you have a class bar that inherits from class foo. And you decorate the class bar as being polymorphic because when you want to serialize properties of type bar, you want polymorphism. But that has, I guess, the side effect of inadvertently opting into polymorphic serialization for anything that is of type ifoo, in contexts where polymorphism wasn't expected at all in the first place. Does that make sense? So if you're let me restate that. If you're opting into polymorphism on a derived class basis, it might make sense for you to specify in relation to which base class you want this to happen, or which interface, which subtype, which supertype in general.
Yeah, that was my dictionary of types to collection of types.
I mean, that's kind of, I think if we ignore interfaces for a second, right? Because I think it seems to me that we look at base types, it's a linear list. And I would say as a derived type, you should be able to know whether that's safe because you clearly know the chain of the base types. I think once you support interfaces, it gets more complicated because, now you have this parallel multi-level hierarchy, right? Where there's no longer a chain necessarily. But that also begs the question, like, do we even want to support interfaces in this model? Like, is that really a thing people want to do?
The design as proposed does support interfaces, and the reason for that is when you do it at the base class level, then interfaces don't become, like multiple interface inheritance doesn't become ambiguous in the context of polymorphism.
Sure, but like I think we already established that that's not workable, right? So we would have to say it needs to be some combination of opt-in at the leaf at the base node, but also at the leaf node. And so I guess if you say you express it in both pairs, maybe, but that seems overly verbose for normal hierarchy.
For what it's worth, if we're sort of to look for inspiration, I guess, on other designs, data contract serializer also specifies polymorphism at the base class level via the known type attribute.
Yeah, that one I think I don't like for the reasons Jeremy mentioned, because basically that only really works when basically the hierarchy is self-contained in one assembly,
Right.
or in your closure at least, right? If the base type is in a base assembly, then you're kind of screwed with that model.
Yeah, so yeah, I'm kind of wondering if we kind of support the happy path that assumes that everything lives in the same assembly, and we provide an escape hatch for everything else via the options API.
Yeah. So I mean, does that? So the known types, or putting something like known types on the base type, meaning that that would be using the static property type for a object tree. Does that mean that the serializer option is? I have the screen, so that dictionary of type to what types are allowed to be substituted for it?
Effectively.
How do you add if that was the case?
I mean, I'm sure that wouldn't be the final shape, but it would be, dare I say, isomorphic to that shape.
That.
I think in
Now,
most
how do I add
cases
more
you
on
set this once. I think in most cases you set this once and not add.
The answer is once you have called serialize the first time, the options are sealed and you can't add more.
Yeah.
Once you start serializing with a set of options, you're done. You have chosen all your options.
Mm-hmm. Yeah, and we already have such a mechanism for sealing custom converters, for example. So. But my concern about that approach is we are effectively forbidding the nuclear option, like the global flag where that just, dumps everything on the wire. Because, some people, if you look at the issue, it's passionate discussion going on. Some people are expecting precisely that. And that kind of brings me back to maybe we should be considering a predicate-like design. Which wouldn't discount the possibility of attributes following the model you showed, Jeremy.
Yeah, I mean, I'm just back to if you have the predicate, how do you know to invoke it? Is it always? Is it member level opt-in? Is it declared type level opt-in? Like that's the part that I don't understand with the predicate suggestion.
Well, ultimately, for a given type, we know what to do, correct? It's not dependent upon anything else.
Well, I mean, that was another question I was going to ask is doing it at the type level appropriate, or is it really a member level decision of when I am my poco.value, these are the types that make sense to be here, but not all foos necessarily want to be polymorphically serialized.
Yeah, so I had a similar question I didn't ask yet, and that's, this proposed dictionary runtime. It does depend upon the type you're trying to serialize as the entry point to the dictionary, the key. So it's just not the simple type to say, hey, I'm polymorphic or not. You have to know the base type, I guess, before you know the derived types. So it's hard to cache that way. If it's just at the type level and you know whether something should be serialized polymorphically, then that makes it very efficient. But in this case, it's dependent effectively the type of the variable being serialized or the element type.
So a quick question on that we can call getType on in a case where we don't want to do any runtime reflection? Was the answer to that yes or no? We cannot call getType in those scenarios. That's reflection, right? Anyone that knows? Because if we can't call getType a runtime, then that means an options-based, serialized options-based feature will not work in such then. It's just not available. I guess we'll...
Why are we saying we can't call getType?
Is that, yeah, that's my question.
I heard it's a performance issue.
Is it performance or is it just
and so I'm just asking, is that going to impact the serializer more than this feature is willing to spend?
Well, I think as long as we have a flag or something to look at to determine whether to opt into this feature, that's fine. We check the global option, the predicate or whatever, and then we call getType.
Well, but
that should be.
If the predicate was Eric's revised declared type and runtime type, then you've already called getType. So it's when do you decide to call object.getType to then invoke the predicate to find out that it returned false?
Right. I just meant the global setting at all, right? I mean, for all types.
Fair enough.
So going back to the original conversation, given that we've established that RCE, remote code execution is not a concern in this particular design, I suppose opting in individual derived types is really stemming from concerns that we might accidentally leak sensitive data from the object hierarchy. So I'm kind of thinking, given that this is an opt-in feature, is that something we should be overly concerned about? And again, I'm saying this being cognizant that object already is globally opted in for everything. And I'm kind of concerned that we might be complicating the API service a bit too much here.
Well, but the difference is object, when you make a member or a property be of declared type object, that is, at this point in the graph, you have made the decision to do one level of polymorphic data emitting. That's not universal for the type. So it's not, any object that could have gone there anywhere else that it appears in the graph did that. So this is changing that notion, and now all of a sudden you're making universal decisions based on type hierarchy that didn't apply previously. So that's right. Sort of where opting in a member of this member wants to be polymorphic is. Now again, you have the question of, is it one level or infinite levels, and such. That's closer to the I declared it as object, but I also want value limiting from assignment, and I want to be able to invoke members off of it without casting and other things. So they are different, and I do agree with Emo's point that we shouldn't design something that works here for writing, and then if we have something later for reading, that it's a completely different system, and we feel that everybody ends up with the two systems needing to always interact, and it's frustrating. So we should be considering deserialization even while saying we shouldn't support it.
Yeah, I think the other question though is to the earlier question of can we just have a hammer and make the hammer opt in? The problem is if the opt-in mechanism is the only way to make general scenarios work, then everybody will use that one global switch, but now they're also opting into a ton of potentially unsafe behavior, and that to me is the anti-pattern, right? We should have a system that is relatively easy to use while also being safe, right? I feel like as soon as we have a mechanism that says you mark a type and now every derived type, and to me whether it's one level or infinite levels doesn't really matter, because even at one level you don't know all people that derive from it, right? So you're still opting in other people's classes, not knowing whether they intended this thing to be serialized ever, right? And I think that's why I don't like this global switch where you just say, yeah, it's opt-in, yeah, but if that's the only way to make it work, then people will use it, and now they have bombs in their code potentially, right? And that seems bad. That's why I think we should make the design usable enough that it's statically, safe, while also making sure that enough things are expressible without people having to resort to a global switch. So if we need a global switch, I think the design is screwed, basically. I guess is what I'm saying.
So I'm picking up on your concern about needing to provide a way to deserialize here. But as it stands, this feature, the way that we're emitting data on the wire, there is no way we could deserialize this in anything that runs a nominal type system, basically. So perhaps the answer then is we should probably focus on the quote polymorphic deserialization feature, which is basically that other thing that emits metadata on the wire. And we only support that design and not this one. And for users that want to just, emit everything on the wire, our recommendation would be, just use object. And there's another aspect worth pointing out here. This feature is very asymmetrical, but in the case of object, there is no asymmetry. And the reason for that is specifically for object, deserialization is possible. It is not real polymorphic deserialization, but whenever you have a property of type object, we hydrate a JSON node or JSON element instance and return that. So in this case, we're talking about a fully round-trippable solution. Right. In this proposed design, there is no round trip as such, at least not in the .NET type system.
Right.
So maybe that is a signal that we should, and again, if you scroll down in the document, I have an open question section, and one of my concerns is we have two things named polymorphism, and I'm calling out the fact that users are bound to be confused by this because they will rightly expect that you serialize using this one gadget. Why can I not serialize it with that other gadget that we'll be releasing in 7? And perhaps one possible approach here is we not call this one thing polymorphism. We call it foo, and we name this other thing polymorphism, and we direct everyone to that.
Yeah, I think honestly that was a driving factor in the 3.0 days for this feature, is that I and others were concerned that whatever we did for just serialization only with no metadata like you have here, the concern was once we add the metadata that it will be confusing and there'll be two sets of knobs, and can both be used, how do you select between them, that sort of thing. So I do appreciate you bringing up that concern, because we almost need to design both features completely and agree on them before we can ship part of it.
Yeah, I think if you have the round trippable one, though, I think people could use that for this scenario as well, right? It would just mean there might potentially be one more property that says, basically either a tag or a kind or a type, right? So that you can deserialize it back into something sane.
Yeah, I would say that it might annoy, JavaScript consumers, perhaps.
Well, but I mean, this is basically round-trippable polymorphic serialization, except don't omit the type identifier. So if we do closed polymorphic serialization, based on that you absolutely have to do closed deserialization in order to be any sense of safe, then it's special casing, which is, I think, Steve Harder's way. Kind of have to design them together in order to get a natural user experience. So I see it as it doesn't have to annoy JavaScript people, aside from if they want JSON.stringify, which is, I don't care what it is, just write it down. And then, to be frank, they can write that in terms of JSON writer or JSON, they can write it. We don't have to provide it for them. We don't provide everything in the framework. Well, that made the room quiet.
Yeah, I mean, to me, I feel like that's kind of what you said earlier. I think is the key part here is we should design the system with deserialization, I guess, in mind, and then see where the differences lie, if there are any. Like to me, the real difference is just you have one more property that has some sort of type identifier associated with it, and that to me just means on the JavaScript side you have one more property than you maybe were bargaining for, but that to me doesn't strike me as a deal breaker.
In some cases, you're changing the JSON type of. So when you're serializing an array, then you're changing an array into an object that nests the actual payload. So that might be a source of frustration for people that are not deserializing the same payload using system text JSON.
So, but why would we do that? Like, why wouldn't arrays stay the same?
So if you're serializing a polymorphic collection type, like a type that is polymorphic but emits JSON that is in the shape of a JSON array, and this is our, for what it's worth, that's also our approach in the reference preservation implementation. We are nesting that array into an object that contains the additional metadata that we need. So this is not just adding another property. That is certainly true for the case of POCOs, but as soon as you go into like more complex scenario arrays, you change the schema of what you're emitting. So again, if you're round tripping with system text JSON, happy days. But if you're sending it to some front end, then it's probably not what they were asking for.
But that's also maybe something that we can just dial, right? To me, it seems, I mean, I understand the difference between, let's say, an array that is of type object array versus string array, but I don't know. I'm skeptical that on the .NET side, you would type something as an object array and then expecting it at runtime to be a string array. Like that seems fringe to me as well. Like I think what you're more likely is you have an array of some base type, and then you have like derived types in that array potentially, so that makes sense, right? But that you could just say arrays are always serialized as arrays. There's no polymorphism there, and it's just whenever we deserialize it, we deserialize it exactly into the type that the object has, right? And that's either an array type or some sort of collection type, but it's all statically noun, and we don't support polymorphism for the collection itself.
Yeah, I wouldn't disagree, but I'm just pointing out that this is already what we're doing with reference preservation. So these are interventions that we're doing to, I guess, to accommodate .NET to .NET serialization scenario, which might leave artifacts for other use cases.
Yeah, that makes sense. I mean, like, when you do things like reference preservation, you clearly can't keep the schema 100% the same, right? But like, yeah, that's an interesting thing. I mean, maybe the deserialization has a few more switches to make it so that the schema is basically backwards compatible to something that JavaScript would like, right? And that might not be as powerful on the .NET side than for example, we couldn't do polymorphic collections, right? And that might be a reasonable constraint for people, or it might not be, right? But we could probably have switches for that. But yeah, it seems to me it's very hard to design just one side. I think it's okay to ship one side if you have a design for the other, but I think I would want to see a design for both sides. Yeah,
the design and implementation is ready for both, but I kind of decided to keep them orthogonal because fundamentally they are orthogonal. They might be sharing infrastructure under wraps because fundamentally they're both polymorphism. But I strongly believe that they are catering to different use cases. Now, that being said, there might be some design hidden somewhere waiting to be discovered where you can magically marry both and
polymorphic deserialization
with some magic.
So imagine you're saving something to a file and you're loading it again, so you're only talking to yourself. If you have the closed set of types that you can deserialize as, then it wouldn't make sense to serialize as something outside of that closed set of types in a polymorphic serialization. So that's where the two blend together. Of the way that the read mode works affects how you would paint things for the write mode, and we want the painting to look consistent. Even if you turn off write down the type identifier so that deserialization could work, it's if you're in the case where you're talking to yourself versus the case where you're talking to somebody doing just JavaScript.eval, or sorry, JavaScript's eval, or the safe thing, JSON.parse, that that you want it to be comprehensible of how you're indicating this type is doing something other than just static serialization, or this member, or whatever. So
Right.
they may end up with, properties on the attributes that say how this is participating. It may end up being some different settings on the serializer, but the way that you indicate the closed polymorphic hierarchy probably should be the same between the two.
What is certain is that you would probably need different sets of attributes for the metadata emitting serialization brand and the non-metadata emitting serialization brand. And that is because when you emit metadata, you would need to specify the subtype identifier in the attribute. Whereas in the, the simple polymorphic case, you don't. So I guess the question is, would we need to shoehorn people into specifying attributes, even if by virtue of some other knob, we stop emitting these identifiers on the wire? Or do we need a separate set of attributes that are appropriately named?
Yeah, that's an interesting question. I mean, to me, kind of what Jeremy said earlier is the key part, which is if you deserialize, you probably need to serialize, right? Polymorphism, right? So then, for the people that need to deserialize, you want to have a set of attributes where both sides are symmetric, right? That doesn't necessarily mean that people that only want to serialize have a different set of attributes. That seems fine to me, because that's kind of, at that point, you're more, I guess, for you it's more important to get the output in the shape that you want, if that makes sense. But I'm catering to the JavaScript guys, so I want to preserve the schema as much as possible and whatever, right? So that might be a more advanced thing, but you need more control knobs, right? But if you only want to deserialize, that presupposes you are serializing, and then you really want symmetry in the attributes, so you don't accidentally get yourself into a situation where you can serialize something that you can't deserialize, or the other way around, right? So that's why I think for some subset of these scenarios, I think symmetry is key. But that doesn't mean that we have to be 100% symmetric, right? It still means there can be scenarios that are outside of that bubble.
Right, like to take data contract serializer, that would be something like the known derived type attribute on the base class, and then if it wanted to support polymorphic serialization, then it also adds a JSON type identifier attribute name or something, right? Like and oh, now it's a read write instead of a write only,
as in an optional parameter in the same attribute,
or a second attribute. So one of them specified the closed type hierarchy, and another attribute specified I can be deserialized, or something like it. But it's write only as a subset of read write, and I think from read write you can decide that there's a way to simplify it to write only. But if we start with write only, we may end up with read write looking completely different, and that feels wrong.
Mm-hmm.
Yeah, I don't see any reason why the known type attribute, as you had in the other design, couldn't be used for the write-only case. I mean, whether or not you specify, a known type identifier, you could, if we want the closed type system instead of the open system, then that makes sense to reuse the same attribute.
I still feel though that we, following what data contract serializer is doing, I would prefer if all these things were defined on the base type rather than opting into individual derived classes. I understand that it feels to me that the canonical use case would define a schema in one project anyways, and I think we should just be providing an escape hatch via configuration for anything else.
What would that escape hatch be?
I
The-
think following
the
the
Boolean
dictionary style,
be everything, or okay,
the dictionary, well, the kind of dictionary-ish thing that you shared earlier, I guess.
that guy.
Yeah. And for what it's worth, a similar design exists in the polymorphic deserialization proposal, which I have completed, by the way. So, perhaps it might be beneficial if we review that as well.
So then, is there more feedback that you're looking for to get, or it should be just table that and say, you may want to go back to the drawing board, or is there more nuance that you want to
this is good feedback. The only thing I'm deducing from this conversation is we kind of made the decision last week to cut the polymorphic deserialization feature from 6 because of the substantial amount of refactoring in sort of the core serialization implementation that it required. So merging, I was hoping we could get this done for 6, but given that we might need to design this in unison, we probably need to push everything for 7 at this point.
Makes sense to me.
And for what it's worth, sorry.
Oh, I was gonna say, in that meeting that we had, an offline meeting discussing this previously, we did have a set of workarounds people have, and we could certainly share that. There's many. So honestly, I don't think people are totally blocked by not having this feature, but it is a super heavily requested feature nonetheless.
I can hear Jeremy's typing. There we go.
All right, so I think a thing that we clearly early landed on is we want closed hierarchy instead of open hierarchy, and then once we got into that state, we wanted to make sure that deserialization and serialization at least are capable of looking the same for the I'm sending to myself polymorphically, and then from that we could come up with a simpler serialization only, which is I'm sending it to JavaScript, but we don't want to do that. Otherwise, we may end up with 2 different models. So I think these are my 2 things, which we then hit needs work, closed. I don't know.
Yeah.
Is there anything that is worth entering into the minutes here that I didn't write down?
I mean, I'd be okay with like approving something for 6 if we still have time, but I am hesitant to do that without having more of a good understanding of what that means for the other side that we're not going to ship in 6. If that makes sense.
In order to get to that point, I would probably need to create a prototype that can provably accommodate both, both features under sort of the revised design. And I'm kind of feeling we're already a bit too late. So if this is not going to make preview 7, then I don't think we should be shipping it at all.
I would agree with that too. Yeah, I mean, we shouldn't rush it. I mean, that's the harder part of the serializer too. So
Yeah,
we should have a
agreed.
design that we're happy with. I just want to make sure that I don't want to be the party pooper here. I just want to make sure that we don't ship something that in 4 months from now we are like, oh shit, what did we do to ourselves? Not that this ever happened.
Never.
All right, so I think that covers this issue.
Yeah.
Maybe fixed by. That's a new one for me. They acknowledge that may and be are two different words. Yeah, I know, we shipped it. I lost. All right. What was your plan for today, Emo?
That was the plan for today, but given that we still have some time left, we should definitely look at the other ones we have.
Do we still have people?
Steven still seems to be here. Steven, do you have enough time for the Debug.Assert?
Sure.
Well, now it's sad that I updated the stream title. All right.
All right, so
that'll teach me.
This is mostly discussion, and then we can decide if we want to do it, and if we do, I think the API largely writes itself. As I think everyone here knows, for C#10, we've added new functionality for string interpolation, where string interpolation isn't just about creating strings. You can write custom builders, and you can then use string interpolation syntax to generate effectively one of those builders. And this allows APIs to define as an argument to a method one of these builders, and then the compiler will if someone calls it with string interpolation, the compiler will generate an appropriate sequence of instructions to generate that builder. One of the interesting things about this is the builder pattern supports conditionality. So you can have two arguments to a method, one that's, say, a Boolean, and one that is the builder. And you can write it such that the builder is given that Boolean before it has to evaluate any of the string interpolation holes. And if it doesn't like the value it's given, it can effectively choose not to evaluate any of those holes. The compiler-generated code basically can generate a branch that says, if some condition according to the builder, then don't do any further work, because the builder doesn't care about these arguments at all. And so, for example, if you're writing a logger, you can use this with the logging builder to check, say, log level. And if the log level isn't of sufficient level to be the level associated with that event, then you can skip evaluating any of the holes associated with that log message, rather than having to manually add a guard clause that says if log level is at least blah, then call the log, at which point you're evaluating the arguments. So this is relevant to this discussion because Debug.Assert is very similar to such a logging method. Debug.Assert basically takes a Boolean and a string message. And if it's very common to see string interpolation for that message, value blah did not fit between the range blah and blah or something, and use string interpolation for those holes. Now, generally, we don't care about those costs because, well, Debug.Asserts are just for debug, typically. But there are variations of this. There's trace assert. And then also, there are situations where it is so expensive to do the thing in the hole that even in a debug build, you can save yourself some pain by putting a guard clause, in which case the ability to not even have to specify a guard is interesting. This particular discussion came about because we had one such case when I had done some work in system random, I'd added a whole bunch of asserts to make sure the right things were happening. And one of those holes was being filled in by a floating point value. And apparently, floating point values toString in debug builds of corelib is like uber expensive. And it was causing problems to the point where we actually added a guard clause around that assert. Because it was causing MS corelib to fall, or corelib to fall over in checked and debug builds. So the discussion was, well, should we consider adding overloads to Debug.Assert that are specialized for string interpolation, such that only if the assert is going to fire, only if the Boolean condition is false, do we want to evaluate the interpolated string? And we could do that if we so chose by writing, just as we've done elsewhere, a custom builder. You can see the arguments, the builder is defined to take that Boolean condition into its constructor, and the assert methods take that builder, exactly, thank you, and the assert methods take a builder as the second argument, saying, or second and third argument, I guess, saying that they are past the condition parameter from the assert. So basically, the compiler will feed through whatever Boolean value is passed as the first argument to the constructor of the second argument, at which point the constructor of the second argument basically feeds that out through that out bool assert. It's a little convoluted, but it works. And that will decide whether all the rest of the append methods that the compiler would generate for the interpolation happen or not.
So in other words, the compiler basically will say if the constructor to the interpolated string handler has an out, it's basically always the condition for whether that is basically guarding all the calls later.
That's correct.
Gotcha. Okay.
And obviously the constructor gets to decide what value that out is set to, and in this case, it would just feed through the condition from the input. So we could do this if we chose to. I think there are two top-level decisions to make here, and then a whole bunch that follow if we wanted to add this. One is, do we care about Debug.Assert? Do we want to, spend more IL in a debug build, optimizing for not evaluating string interpolated holes? It's a debug build, so we probably don't care about IL size, but it's additional methods here, and it's some additional complication, etc. The nice thing is, every place where we do, you never, assert should never fire. So all the work that you do in string interpolation in the message to an assert you do it all the time, and it should never matter. So this would eliminate that work in a debug build. The more interesting discussion to have, and this is a discussion that one can also have when talking about logging, is we would be taking something that currently always happens, and we would basically be turning it into something that effectively never happens. So if someone had a mutating, some mutation inside one of the holes, they did X++ as the hole in the string interpolation, previously that would have run in a debug build, and now it won't. My personal...
It would run in a release build, though.
Well, it would not run in the release build, that's correct. And so my personal opinion is, well, if someone's doing that, I'm kind of okay breaking them. Again, only in a debug build. But it's a discussion worth having, probably.
I mean, I can definitely say that for private tools that I've written myself, I think in 16 years of being a .NET developer, I've switched Visual Studio to release mode like 4 times. If it's a little tool for myself, debug is the only build I ever build because it's the default, and I don't care. So the it's just debug, it doesn't matter. Actually, basically, it's every application, or 90-something% of applications. But our answer for people is, if between .NET versions, don't do major version roll forward and test your app before you release it. So I think that if you have mutating assert messages, you would figure it out quickly.
Yeah.
I mean, in the library, you're never publishing your debug build. or you probably shouldn't be, right, to nuke it. So, I mean, I guess I don't.
Well, for a library, it still comes down to they would have to recompile. Like, because if you write the $quote syntax and we don't add this, or you compile against a TFM that doesn't have this, then that gets built as a literal string unconditionally, which is the work that Steve's proposing we avoid here. It's when you recompile against .NET 6 that now it would turn this into the conditional statement and not run the string concats.
Right, and that's a key thing I didn't mention, but the compiler, from an overload resolution perspective, the compiler prefers arguments that are builders over arguments that are strings. So when you did, we would just recompile, our build, and all of a sudden we're getting the new behavior, which we'd be adding this exactly because of that, right? This would have no value if that weren't the case.
Yeah.
So from my perspective, and others can disagree with me, if we think that saving these costs in debug builds is worthwhile, then this seems like a pretty reasonable thing to do.
I mean, we've already hit a case, right?
We did, yeah.
Yeah, so to me, I can see where there's a risk in breaking it. This is the kind of thing that is very much this isn't a runtime break, it's a recompile break, so major version roll forward actually doesn't even affect it. This is a you had to recompile your code, and every time you build you should test. Especially if you've changed your TFM. And so the people that it would break seem minimal, and we do know places that it would be valuable, and frankly, the more debug is like release, the more you can do sane testing with debug. So I think it's all virtue. It's like when Windows did the major effort to get rid of all their tripping asserts, so people could actually try running debug builds. To me, this is goodness.
I agree in general. At first, I was like, why would we even care? But then when Steve said, well, here's an exact case, it's like, well, other people are going to have those kinds of cases as well. Like, it's kind of annoying that core CLR, you can't really use a debug build of it, or I can't, because as soon as you run tests, they take forever, right? This doesn't solve that, but it's in that vein, right?
Right.
So I think we should do it, assuming, I think we should at least approve it. Maybe we don't necessarily have to do it in 6, but I see no reason why we shouldn't approve this API.
I mean, the work here is really simple, so if we approve it, it would take a couple hours to get it done.
Yeah, and then I was thinking you didn't need to out the bool asserted because the append formatteds could all just, the append literal could just ignore it if the condition was false. But I agree, outing the bool and making the compiler write the if means we don't even pay the method entry exit cost. So,
well, the bool is required because if you don't have the bool, then the compiler, you are going to end up executing. You're going to end up calling all those append methods, at which point the argument to those methods will have already been evaluated.
Right. So if it was a method call
fair
to get passed in.
Right.
Okay. So it would avoid the string concats, but it would
avoid, and it would avoid
run side effect code, and
right.
Yeah.
It would avoid the cost of a toString, but if we chose to ignore it, but it wouldn't avoid whatever code was required to compute the value passed to these methods.
Right. You have I got an identifier I didn't expect. The things I expected were, and then open curly string.join, do some other things. It's like
exactly.
You still called string.join, and with
Right.
this approach you don't. So
right.
Yeah. So definitely for Debug.Assert, it seems good to me. I don't know what trace assert does.
Trace assert is like Debug.Assert, except not limited to debug builds.
It's limited to trace, right?
Maybe.
I believe so, and I think trace is defined for release as well. I think that's the default configuration.
Right. So that one is slightly more interesting now in the side effect encode because that still ran in release builds and now it wouldn't. Again, I'm still of the opinion that you changed your TFM and rebuilt. Like, you should have noticed that your X++ didn't happen.
I mean, that's generally the bar, right? I think if any, I mean, it's sad if something super subtle on recompiled changes without any errors, but I have to say we have done more impactful breaking changes, and it was fine. I mean, when C# decided to no longer capture for each variables, for example, I mean, sure, somebody broke somewhere, but I think it's for the better, and I would say this is in the same vicinity to me. I mean, my other question would be like, you didn't talk about logging, but didn't logging have the same desire at some point?
Yeah,
Like-
we haven't gotten there yet.
I see.
And then, yeah, so then now we move next to the we coulds and debug write if and debug write line if. Again, it feels like people who write that kind of don't think about the cost of the thing that goes after the comma, because in their head it is exactly this. It didn't matter unless it was going to do work. Unless the condition failed. So it seems totally reasonable to me. Certainly trace assert and debug assert both get to name their internal type assert interpolated string handler. Assuming that the debug write if is backwards though, right? Because that would be if the condition's true, do the work.
If the condition is true, do the work, yes.
And assert is if the condition is false, do the work. So it would want a different.
That's right.
It would need a different type.
We would need a different handler for write line. We could use the exact same one, like we could use the exact same type for debug and trace, and then it's just a question of, where do we put it? Are we okay with trace referring to a nested public type inside debug, or would we want to put that type somewhere else? I have no concerns either way. We've hidden it from IntelliSense. It's not meant to be used.
Do we? Yeah, Emo, have you seen any proposal as to what this is going to look like in IntelliSense? Okay.
No. I mean, my general assumption is like, unless, I mean, it's probably not pretty right now, but it's probably also not the worst in the world. And unless these APIs are way more mainline, I don't think they will ever do a feature that does something special in the IDE, because it's probably not worth it for the 6 sites where we use it today, right?
I think there's going to be some feature, I just don't know what it's going to look like for builders, where IntelliSense is going to treat them specially. So when you .assert open paren, you'll see some special syntax that suggests you can do an interpolated string here, but I don't know what that's going to look like exactly.
Well, that's kind of what I meant. Like, to me, it's kind of, unless we use this in more places, I'm skeptical that this makes the bar.
I mean, Debug.Assert may itself be enough people see it that it becomes worth doing.
Yeah,
so
that's possible. Yeah.
But that's where if IntelliSense, assuming that you're on the current version of VS, etc., if that's not even going to show the type name of the builder, then I would seriously not care if trace was reaching across and accessing an internal type off of debug. Sorry, a nested type off of debug. But if they're going to show up, then that's where it's like, the struct is small. Maybe we just copy and paste it as a nested type to follow our pattern and shrug. Because the debug one should, in a release build, shouldn't appear, and it should trim out of the final application because all the conditional calls would go away, so the type usage would go away. The trace one would survive if you call trace.
Yeah, I mean, it saddens me a bit that we can't easily share them, but
yeah. But I mean, this does. I don't remember the pattern, even though we only made it up like a month ago. But I do feel that it was primary method name interpolated string handler as a nested type on the type that was going to use it, and so that just means we would copy it. Just because trace and debug are the same thing split across two types, so they end up with the same thing split across two types. So.
Yeah, I'm fine either way. Like, I wouldn't lose sleep over if they used it.
All right, so I think we're saying yes, and also to all the weak hoods.
I believe so.
An Uber question I have is, do we just do these one at a time, or do we take like a holistic approach to places where people want to put strings in interpolated? Like for example, event source, right? What's our Uber approach to when and where we should introduce these in APIs?
I mean, I think unlike span, where it was, every API might need to take spans, there's a much more limited subset where this is relevant. Here, it's either there's some conditionality, so there's an efficiency argument related to that, or there's some special way the formatting needs to happen, and so the builder is relevant to that. There's one other place I'm aware of that we've identified, which is text writer. There's an open issue for that. But even for something like event source, I'm not entirely sure what that would look like, because it's generally strongly typed in terms of the events. Someone on it writes their own custom event source with their own custom logging methods that takes the exact data types they care about, and then it's up to the implementation of that method what to do. And it needs to kind of store the data in a fairly strongly typed way as well, and it's usually not doing it as a string. So I don't know exactly what that would look like. You could imagine, like today, the pattern is generally if event source, my event source .log is enabled, my event source .log.foo. I don't know how we'd write a generic builder, an arbitrary builder to use in that foo method that would check that particular event source is enabled. Maybe it would. There is the facility to pass in this as an argument, so maybe we would do it that way, and then we wouldn't actually ship any APIs for event source, but we would ship a builder that someone could use in their own event source methods. That would sort of do the right thing, but that probably requires more thought. I don't know if there are any others. To your question about Uber, we've sort of addressed the main use cases we knew about, and then I think we've sort of been treating it as more arise, we can add more. Like UTF-8 formatter, we sort of said, well, we don't know if someone would actually care or use it, so let's wait for feedback. But if there are others you think are useful, we could certainly consider them.
Okay, I think you answered my question with the first part. What about it's only really when there's a conditionality aspect or a specialized formatting,
right?
Where
so
this really makes sense.
The places where we have them so far are we have some overloads of string.create that allow you to customize the formatting via an format provider or with some pre-allocated buffer space, and we have one for writing into spans instead of creating strings. So again, controlling how the formatting happens. And then this is the only other one that we've decided on, and this is the conditionality one. We have an open issue around text writer because we have one for string builder too, which is about formatting directly into the string builder. And the one for text writer is similar to that. It's, we'd have to figure out exactly what it means, but maybe it's emitting a write call for each individual thing or specializing, the formatting to do it more efficiently into its internal buffer or something along those lines.
Okay.
I do think we should strongly look at one for the extensions logging stuff. I think that's a valuable place to do something.
Yeah, that'll probably be 7.0 time frame.
Yeah, that's fine. I think
Do we have an issue on that at all? Do you know?
I don't know. I mean, I was pushing pretty hard for it when we were talking about the source generator stuff, but all the effort got focused on the source generator stuff. So.
Where are you, long line? All right. System diagnostics, debug, assert, boolean, interpolated, and assert, boolean, interpolated, interpolated with the assert handler. Write if with interpolated and interpolated comma string, because I don't think we care about special formatting category based on the name category.
I would assume so, yeah.
And then take the two writes and make the right lines. These all use the write if interpolated string handler. And then I copy and pasted this for trace, except I removed the two does not return ifs on the asserts because that I made an assumption.
Correct assumption.
Okay, because so it looks like it's asserts, except they aren't non-returning, and then writes and write lines.
Your conditionals are all messed up though.
Yeah.
Yeah, they're all trace, not debug on trace.
Thank you.
I know that it matters, but I guess no, it does matter because it's actually the new type, right? Add new methods, yeah. And why does the assert not return? I mean, the assert will fail fast too, right? Presumably.
The assert will, the trace won't, is what Steve said.
Oh, trace doesn't do anything when the assert fails.
I honestly don't know what trace assert does. I think it just emits an assert message to the underlying, or a fail message to the underlying trace listener, but I have to double check. I mean, technically, even Debug.Assert, like the 99.99999% case is that Debug.Assert fail fasts if you pass in false. It is possible to plug in to delete all the existing trace listeners and plug in your own that causes that not to happen. But for the purposes of nullability, we basically said it's 100%.
Right.
Yeah, the default trace listener.fail is just write line a message. It doesn't also then exit the process.
Sense.
So, all right.
Makes sense then. Jesus, we still have 15 minutes left. Might be able to do the other one as well. I guess nobody's here.
Yeah, we don't have the people here for that. I don't know that we can say that we still have quorum.
No, I don't think we can. I just looked at that. I think at this point we just have to say
we had quorum when we started that issue, and everybody who left gets an implicit abstain. But I don't think we have quorum now. So
no one else cares about debug builds.
Apparently.
Is there any really easy one on here?
I mean, is there any easy one that we think that only 4 people is enough to say approved? That's the
most of these look like analyzers.
Meaning you think they're easy for us to just give permission to, or that they're long debates?
I wasn't implying anything by it. I was just speaking my thoughts aloud.
Okay.
You scroll down just a tad.
That's the bottom. Or object dispose exception overload is the bottom.
Looks like we get 11 minutes back.
Sounds great.
Yeah.
All right.
Enjoy your lunch, gentlemen.
Oh, I didn't use the gavel to open, but I can use it to close.
All right. See you next week.
See ya.
Enjoy your weekend.
Bye, everyone. Wait, there's an order to this. I have to